Hi everybody, it's Mrs. Dunn again. So what we're going to do in this last screencast for chapter 1 is we're going to talk about solving linear inequalities. So what we're going to learn is how to solve a linear inequality. We're going to talk about graphing the solution to an inequality, writing the solution in interval notation, and we're going to solve some compound inequalities. Okay, so before we get started, we need to talk about a couple things. So let's look at some examples. So what I want you to do is consider this statement, 3 is less than 5. Okay, 3 is less than 5. That's a true statement. So a couple things. Can I add the same number to both sides of that inequality and maintain the truth of that inequality? So for example, if I added 7 to both sides of the inequality, then I get 10 on the left and 12 on the right, and 10 is indeed less than 12. Okay. What if I subtracted the same number from both sides? Is that statement still true? Well, yeah, because 3 minus 7 is -4, and 5 minus 7 is -2. So yes, it is still a true statement. -4 is less than -2. All right, what about multiplying? If I multiply both sides of the inequality by the same number, these are all things we're allowed to do with equations. And as it turns out, we can do those with inequalities. So if I multiply by 4 on the left and 4 on the right, I get 12 is less than 20, and that is true. But here is where things get a little wacky. If instead of multiplying by a +4, I was to multiply by a -4, well, on the left side, I'm going to get -12. On the right side, I'm going to get -20. And -12 is not less than -20. Actually, it's greater than -20. So that's an important principle you're going to have to remember. When you multiply or divide by a negative number, you have to remember to change the sign. So notice that less than sign changed to a greater than sign. So there's a box in your book, which I felt was really well done, indicating all of these properties. So what this is saying is that you can add and you can subtract and nothing's going to change. But if you're multiplying both sides of the inequality by something negative, then you have to remember to reverse the inequality sign. Okay, let's go through a couple examples. I believe I have 4 examples here that I want to work through, and this should help you with your homework. So solve the inequality and graph the solution set. So basically, when you're solving an inequality, you're going to do that the same way you solve an equation. So if this was an equation, we would combine our x terms together, combine our numbers that don't have x's in them on the other side. So, for example, I'm going to add 2x to both sides, and then I'm going to add 5 to the other side, and then divide by 5. So x is less than 11/5. Now, what changes with inequalities is now we have to graph that solution set. So the solution set is going to be all those numbers that are less than 11/5. So this is what that looks like on a number line. So label 11/5, and we use a parenthesis to indicate that we're not including that number 11/5. Okay, so the parenthesis is what you use when it's a less than symbol. Okay, that means we're not including 11/5. It's all the numbers up to 11/5, not including an 11/5. We also have to write this answer in interval notation. So what this looks like in interval notation is it's all the numbers from -infinity up to 11/5, not including 11/5. That's what the parenthesis means. Okay, let's look at example 2. Now example 2 is 13 minus 7x is greater than or equal to 10x minus 4. All right, so we solve that like it's an equation. We're going to combine our x's together by subtracting 10x from both sides. And then we'll subtract 13 from both sides. And then divide by negative 17. And remember, because we're dividing by a negative, we have to change the sign. That's one thing that a lot of students forget to do. Don't be that student that forgets that. So when I change the sign, it's now x is less than or equal to 1. And we're going to graph that solution set. All the numbers that are less than or equal to 1. So we use a bracket in this example because 1 is included in the solution set. Now, what does that look like in interval notation? Well, it starts at negative infinity and it goes all the way up to 1, and we're including 1, which is why we use a bracket. Okay, a compound inequality is next. So solve the compound inequality and graph the solution set. This is an example of an AND statement. So 2x plus 5 is greater than negative 3 and less than or equal to 7. Let me say that again. Negative 3 is less than 2x plus 5, and 2x plus 5 is less than or equal to 7. This is an AND statement. Now, what we're going to do is we're going to treat this like it's an equation. And if this was an equation, we would subtract 5. But we're going to subtract 5 from the left, the middle, and the right. So when I subtract 5, I get negative 8 on the left, 2x in the middle, and 7 minus 5 is 2 on the right. Now we're going to divide everything by 2. So the solution is negative 4 is less than x, which is less than or equal to 1. Now, what does the graph of that solution set look like? Well, it's all of those numbers from negative 4 until we get to 1. We don't include negative 4. That's why there's a parenthesis. But we do include positive 1. That's why we use a bracket. All right, one last example. I want to show you an example of an OR statement. So sorry. I want to show you the answer in interval notation. So that answer in interval notation goes from negative 4 to 1, parenthesis on negative 4, bracket on 1. Okay, now we'll talk about this OR statement. So this is a compound inequality that is an OR statement. So 2x minus 5 is less than or equal to negative 7, or 2x minus 5 is greater than 1. So we're going to do those two inequalities, and we're going to solve them similar to how we would do an equation. We're going to add 5 to both sides. And then we're going to divide both sides of the inequalities by 2. So we get x is less than or equal to negative 1, or x is greater than 3. So what does this solution set look like when we graph it? So we have all those numbers that are less than negative 1 and all of the numbers that are greater than 3. So there's two parts to our graph. So it's all of these numbers up to negative 1. We include negative 1. That's why there's a bracket. And then from 3 to infinity, but we're going to use a parenthesis. Look at what this looks like in interval notation. So in interval notation, it's negative infinity to negative 1 with a bracket, and then a union symbol, that means OR, all those numbers from 3 up to infinity. And 3 is not included, which is why we use a parenthesis. All right, good luck. I hope you have fun with this section. Email me with any questions.